Cells have high intracellular potassium and low extracellular potassium, while they have high extracellular sodium and low intracellular sodium. This means potassium wants to leave the cell at approximately the same rate that sodium wants to enter the cell. Since cells are actually more permeable to potassium than they are to sodium, this means that potassium will leave the cell at a greater rate than sodium will enter the cell. This causes a net loss in the number of positively charged ions on the inside, while on a proportional level, the number of negatively charged ions on the inside rises, causing the inside of the cell to develop a negative charge known as a membrane potential. This membrane potential pulls the potassium ions backwards and decreases the rate at which they can leave, and pulls the sodium ions inward and increases the rate at which they can enter. Eventually, the membrane potential will become negative enough where the rate at which potassium leaves will be slowed down so much that it will actually leave the cell at the same rate that sodium enters the cell. This is known as the resting membrane potential.